Now let us solve question number 7. Maximize and minimize the objective function z is equal to 5x plus 10y subject to the constraints x plus 2y less than equal to 120, x plus y greater than equal to 60, x minus 2y greater than equal to 0, and the non-negative conditions x greater than equal to 0, y greater than equal to 0. So in this question we have to maximize the objective function as well as minimize the objective function. Let us consider the equation corresponding to each of these inequalities. So let us start. Equality corresponding to x plus 2y less than equal to 120 is x plus 2y is equal to 120. This represents a line. Let us talk about the intercepts of this line. So at y is equal to 0, we put y equal to 0, so x equal to 120. The x-intercept is 120. If you put x equal to 0, you have 2y equal to 120. So y is equal to 60. So for this line, the x-intercept is 120 and the y-intercept is 60. So when y is 0, x is 120, and when x is 0, y is 60. Now we leave the blank spaces because we need to find the intersection of this line with the line's equations corresponding to these two. Let us go for the second one. Equality corresponding to x plus y greater than equal to 60 is x plus y is equal to 60. Now this represents a line whose x-intercept is 60 and the y-intercept is 60. So when y is 0, x will be 60, and when x is 0, y will be 60. Because the graph is not going to be scaled, it will be difficult to get the point of intersection from the graph. So better we get the intersection from here by solving them. If we subtract equation number 2 from equation number 1, see, x minus x is 1, 2y minus y is y, 120 minus 60, y is equal to 60, and when y is 60, x will be 0. So 0 comma 60, that is the point that you get in both the cases. Now the third one. Equality corresponding to x minus 2y greater than equal to 0 is x minus 2y is equal to 0. Now this one, x minus 2y is equal to 0, it represents a line passing through origin because there is no constant term. When the constant term is 0, the line passes through origin. Here x is equal to 2y. So if we substitute x equal to 2y, so 2y plus y, 3y is equal to 60. Now 3y is 60, that means y is 20. Y is 20, then x is 40. Now x minus 2y is equal to 0. If we take x equal to 2y and substitute here, 2y plus 2y, 4y is 120. 4y is 120, that means y is 30. And when y is 30, x will be 60. The non-negative condition suggests that the feasible region that remains in first quadrant. Now let us try to draw the graph. If we have a look at these plottings, what we find is the maximum x coordinate is 120 and the maximum y coordinate that we find is 60. Okay, let us do it this way. The y-axis, the x-axis. Let me have a scale of 20 units. So 20, 40, 60, 80, 100, 120, 140. 20, 40, 60, 80, 100, 120 and 140. So let us go for this one. The x-intercept is 120 and the y-intercept is 60. So here is the x-intercept and here is the y-intercept. Let us draw this line. It is x plus 2y less than equal to 120. This intercept is 120, 0 and here it is 0, 60. The feasible region corresponding to the inequality x plus 2y less than equal to 120. Now at this point, the x coordinate is 120 and the y coordinate is 0. If we substitute y is equal to 0, x will be less than or equal to 120. So when x is less than equal to 120, so you move this side. So the feasible region is the below half plane. Now we respect the non-negative condition. So in that case, the feasible region corresponding to this inequality is a right angled triangle. I shade it using vertical waves. We go for the other one. The intercepts are 60, x-intercept is 60 and the y-intercept is 60. The inequality is x plus y greater than or equal to 60. At y is 0, this point is 60, 0. At y is 0, x will be greater than or equal to 60. So we move to the upper half plane. So let us draw vertical dotted lines for this one. Actually, we are respecting the non-negative conditions, so we are not going below this x-axis. And these two lines, they intersect at 0, 60 at this point. Now the third one, the line passing through origin, it meets the first line at 60, 30. So this is the first line, 60, 30, somewhere over here. And it meets the first line at 40, 20. This inequality is x minus 2y greater than equal to 0 passes through origin, intersects the first line at a point 60, 30, intersect the second line at a point 40, 20. The inequality is x minus 2y greater than equal to 0. Now this point is 0, 0. At y is equal to 0, x will be greater than equal to 0. X is greater than equal to 0. Move this side. So this is the feasible region. So we use slanting lines to draw the feasible region. Now we talk about the common feasible region or the feasible solution region for this linear programming problem. So it is the region where you can find all the three kinds of shading. We use three kinds of shading here. We use the vertical noodles or the vertical waves, we use vertical dotted lines, and we use the slanted lines. So if you look at this properly, what you find is that it starts from here. Let this point be A, 60, 0. From A, we move along the x-axis till this point B, 120, 0. Then from this point, we move along the line x plus 2y is equal to 120 to reach a point, we call it C, 60, 30, and from there we move along x minus 2y greater than equal to 0 to reach this point which we call D, 40, 20, and from this point D we travel along x plus y greater than equal to 60 to reach back at A. So the feasible solution region here in this case is a bounded region, is a quadrilateral A, B, C, D, and then come back to A. So we have the common feasible region, the corner points A, B, C and D. Let us get the value of objective function for these corner points. So we have 4 corner points. First one is A, 60, 0. The second one is B, 120, 0. The third one is C, 60, 30. And the fourth one is D, 40, 20. The objective function is z equal to 5x plus 10y. So let us compute the value of objective function for each of these corner points. So at A, 60, 0, y is 0 and x is 60. 60 into 5, 300 plus 0. So the value is 300. At B, y coordinate is 0, so 10 into 0 is 0. X coordinate is 120, 120 into 5, so that makes it 600. At C, 60, 30, you take x is 60, 60 into 5, 300, y is 30, 30 into 10, 300, 300 plus 300 is 600. At D, x coordinate is 40, 40 into 5, 200, 20 into 10, 200, 200 plus 200, 400. So we want to minimize as well as maximize the objective function. So which is the minimum value? So here is your minimum value. So minimum value is 300 at x equal to 60 and y is equal to 0. Minimum value for z is 300 at capital A 60 comma 0. We talk about the maximum value. Now there are two maximum values at B and at C. So these are the two maximum values. So the maximum value, it lies along a line joining the points B and C. So maximum value of the objective function, it lies along this line joining the points B and C. So simply we write maximum value of z appears on the line joining the points B here is B, sorry, this is B and C. And C 60 comma 30. B and C, this is the line at which you get the maximum value for the objective function.